All right, this video is going to be a big overview on adding and subtracting unlike fractions and mixed numbers. If we need to do a deeper dive into some of these details, just let me know and I'll make another video. All right, so every time we're going to add and subtract fractions or mixed numbers, remember fractions and mixed numbers are those quantities that fall between our whole numbers, something between 0 and 1. Something between 1 and 2, or 2 and 3, or 3 and 4, okay? When we add and subtract those numbers, we're gonna follow 3 big groups of steps each time we do it. Of course, we're always gonna estimate before we begin. After that, we will create like quantities. In our last video, we talked about like and unlike fractions. If fractions are unlike, they don't work together. We can't add them, so we need to change them into like quantities. Then we need to manipulate or compute the numerators. Next, we will simplify the sum or difference. Now, I've used this color code throughout my work so that you can see which step I'm really working on as we find these sums and differences. So when we create like quantities, that will be in dark blue. When I manipulate or compute numbers, that will be in pink. And when we simplify our sums or differences, that will be in blue. Remember, simplification may or may not be necessary. Of course, at the end, we'll always go back and check our quantity and make sure that it makes sense. See that we're not making mistakes. All right, so let's start with adding fractions. I've chosen the fraction 3/4 and 5/6. As you can see, fourths and sixths are not the same. So that means these are unlike fractions. The first thing we need to do is to create like quantities. We can do that in a lot of different ways. But the main idea is that we're looking for the least common multiple, or LCM, of the denominators. One way to do that is through skip counting. So I've created a little skip counting pattern right here for 4. We know we can count by 4s, 4, 8, 12, and we can count by 6s, 6, 12. Look, those denominators are in common. Next, we do the same thing, skip counting by the numerators. 5/6 is the same as 10/12 because we count 5, 10, 15. 9/12 is the same as 3/4 because we count 3, 6, 9, 12, etc. Okay? So here I've replaced 3/4 and 5/6 with their equivalent fractions, okay? These equivalent fractions have the same denominator 12, so now they're like apples and apples. We can add them. 9/12 plus 10/12 is the same as 9 apples plus 10 apples, so that gives us 19/12. Now, we look at this fraction, and I notice the numerator is bigger than the denominator. When the numerator is greater, that means we have an improper fraction. So we can simplify it by converting it into a mixed number. 9/12 is the same as 1 whole, so I took away those 12/12, and 7/12 left over. So now we have our final answer, and we need to check to make sure it makes sense. 3/4 is between 0 and 1. We can tell that because the numerator is smaller than the denominator. 5/6 is also between 0 and 1. So the smallest answer we could have gotten would be something close to 0, because 0 plus 0 is 0. And the largest or greatest answer we could have gotten would be close to 2, because 1 plus 1 is 2. So we're looking to make sure our answer is between 0 and 2. It absolutely is. 1 and 7/12 is between 1 and 2. So that fits in to what we think is reasonable for an answer for this problem. Our sum is 1 and 7/12. Next, we're going to subtract some fractions. I've chosen 9/14 and 1/4. So we're going to subtract those. 9/14 is less than 1, and so is 1/4. So we're going to imagine that our answer has to be less than 1. If I start with something, for example, I start with less than a whole melon, and I subtract some, there's no way I could have more than a melon, okay? So we're gonna go with less than 1 as what we expect for our answer. First, we need to create like quantities. So here in dark blue, I've done our skip counting again. I found out that 9/14 is the same thing as 18/28. And that 1/4 translated into 28 is the same thing as 7/28. Notice how easy it is when I do skip counting. Here I'm counting by 4s, 4, 8, 12, 16, 20, 24, 28. And here I'm counting by 1s, 1, 2, 3, 4, 5, 6, 7. Couldn't be easier than that. Now you can also use times tables. You can also use cross multiplication if you know those methods to find the least common multiple. But this is going to be the simplest way. Now I'm going to take those equivalent fractions that I found that have the common denominator, and I'm going to replace those into my problem. Here, I know that 9/14 minus 1/4 is the same thing as subtracting 18/28 minus 7/28. Did you hear that? 28s, 28s. That's just like apples and apples. So let's subtract across the top. 18 minus 7 gives us 11. So 18/28 minus 7/28 gives us 11/28. Now here, I don't need to simplify because 11 and 28 don't share any common factors. The only common factor they have is 1. And we know that dividing by 1 gives us the same answer again and again. So we don't need to do anything else. We have our answer, 11/28. And look, our numerator is smaller than the denominator, so we know that quantity is between 0 and 1. Perfect, just like we predicted. All right, let's move on and look at adding and subtracting when we have a mixed number. Now, it's basically the same process, but it's sort of like as if we were adding and subtracting two-digit numbers. We look first at the ones column and then we look at the tens column. Well, we're going to do the same thing, separating the partial quantities like fractions from the whole quantities as we add and subtract. There's other methods to do this, but I'm going to show you this way because it's the way we learn in our class and it's a bit simpler to comprehend, okay? So let's start with the addition, which is actually on this side of the page. I've chosen to add 1 and 1/2 with 3 and 2/3. So you'll notice that I have two whole number quantities, 1 and 3, and I have two fraction quantities, 1/2 and 2/3. First, I'm going to add my whole quantities. I've skipped a step. I'm already manipulating or computing, so I've written that in pink. So this number sentence is the same as 4 and 1/2 plus 2/3. If this is confusing you, another way to think of it is to break down all four of these quantities like a really long addition problem. So you can think of this as 1 plus 1/2 plus 3 plus 2/3. And because addition is commutative, we can move that order around. So we can think of it as 1 plus 3 plus 1/2 plus 2/3. So when we start and do 1 plus 3 first, we get 4. And then we still have 1/2 plus 2/3. Okay, so now we're going to continue. Now we have these two fractions, half and thirds. They are not like fractions. So we need to change them and find a common denominator to make these quantities alike. Our common denominator with 2 and 3 is 6. That is our least common multiple. If you're not sure how to find that, go back up and do that skip counting up here. Now I'm going to put these quantities over 6. 1/2 is the same as 3/6, and 2/3 is the same as 4/6. So now I have completely substituted those equivalent fractions for the fractions I began with. And I continue writing. Notice, I don't forget that 4. That 4 didn't disappear. I'm just working on the fraction part, but I still remember the whole number as I do my work. Next, I'm going to add these two together. Well, when I add 3/6 and 4/6, I get 7/6. That's a little bit more than 1. So we simplify that and make that 1 and 1/6 here. We're still adding it to the 4. We can't forget that whole number just because it was the first step we did. Next, we're going to add those whole numbers together. 4 plus 1 is 5. And we're going to add that to 1/6. And now at the end, we end up with 5/6. This method is much simpler than changing all the fractions into improper fractions. The reason being because as we manipulate greater and greater numbers, we run the risk of making more computational mistakes or mistakes in adding, subtracting, multiplying, and dividing. Okay, so by separating the whole and part quantities, we're thinking more like we would naturally in a mathematical situation, and we are not risking playing with those bigger numbers. These numbers were all really small, and the computation was quite easy. All right, this is adding mixed numbers. Now let's check our answer. Does 5 and 1/6 make sense as a sum for these two fractions? Well, this mixed number is 1.5. It's between 1 and 2, but we say that it's closer to 2 because at the half we round up. So this is about 2. 3 and 2/3 is between 3 and 4, but it's past the halfway mark, so we're going to say it's closer to 4. 2 plus 4 is about 6. 5 and 1/6 is pretty close to 6. So that means we've done our job. Now let's move over and try our last problem. This is a subtraction problem. This is where some students might have some difficulties. So I've chosen a problem that requires regrouping, much like when you're subtracting 12 minus 7. You go 2 minus 7, but the 2 is too small. Well, we borrow that 10, we bring it over, and we actually do the whole quantity 12 minus 7 all at once, giving us 5. So we're going to do that same type of regrouping here in this problem, but we're going to be using fractions. Look closely for the purple note to see when that happens. Here I've chosen 2 and 1/4 minus 1 and 9/10. We know that 2 and 1/4 is a greater quantity because the mixed number, the whole number portion of the mixed number is higher. So we're good to go. We have a correct minuend and subtrahend. We can find the difference. Okay, so we're going to start this one the same way we started the other one. We're going to look at those whole quantities. 2 minus 1. Now, isn't that easier than pi? 2 minus 1 is just 1. So we replace both whole numbers with just this number 1. And now we're going to rewrite the fraction quantities. So 2 1/4 minus 1 and 9/10 becomes 1 1/4 minus 9/10. We've taken away that one. Now, 1/4 minus 9/10. Our minuend is smaller than our subtrahend. We cannot subtract. That means we need to borrow. So we're going to take from the whole number category 1 whole. But we're going to represent that whole as fourths. We're moving it to the next place in place value. Well, how many fourths are in 1 whole? Let's think about it. If I take my grapefruit and I cut it into fourths because I want to share with 3 other friends and myself, each of us will have 1/4. That means there's going to be 1 for me, 2 for another friend, 3 for another friend, and 4 for another friend. There are 4 fourths in 1 whole. It's in the title, fourths. So when we take away this 1, we're going to write 0 for 0 wholes. 1 minus 1 is 0. And we're going to replace that 1 over in our fraction category, writing 4 fourths, because there are 4 fourths in 1 whole. Now we're going to put those quantities together so that we can see if we have a fraction where we can subtract. So here, 1/4 plus 4 fourths gave us 5 fourths, and we're still trying to subtract 9/10. Now 5 fourths is greater than 1, so we're ready to subtract. All we need to do is create like quantities. So we have our first fraction in fourths and our second fraction in tenths. Those are unlike. So we need to look for the LCM, or least common multiple. We find the least common multiple, which is 20. 5 fourths is the same as 25 twentieths, and 9/10 is the same as 18 twentieths. Now we're ready to manipulate those numerators. Let's subtract. 25 minus 18 gives us 7, and we keep that denominator the same. No need to do anything to that denominator. Now we're going to check to see if we can simplify by dividing by that greatest common factor. But it turns out the only common factor between 7 and 20 is 1. So there's no use in dividing it. It is already simplified. I hope that you've enjoyed learning how to add and subtract fractions and mixed numbers. In each problem, we wanted to estimate at the beginning to make sure we know where we were going. Next, we looked at those ugly, unlike fractions, and we made them into like quantities using skip counting and finding equivalent fractions with common denominators. Next, we manipulated the quantities, either adding those whole numbers together, or we went adding those numerators and keeping that denominator the same. Finally, we looked at our last answer, determined if we needed to simplify by dividing by the greatest common factor, or if we just left it the same, and we could compare with our estimation to make sure that our answer was reasonable. I hope you've enjoyed this video. Please let me know if you have any questions. Thank you.